Hello. Now, continuing our work with circles, we are going to be looking at the equations of circles that are not centered on the origin, that aren't centered at 0, 0. So this is just the more general situation that we talked about a little the day before. So we've got our circle here, and it's now centered at x1, y1. So it's no longer down here centered on the origin. So now the definition of this circle is going to be all of the points that are the same distance away from x1, y1. So we're going to use the distance equation again, and the distance from the center out to the circle is the radius. So the distance formula based on Pythagoras is going to be the radius is equal to the distance from any point on the circle to the center. Now if I square both sides to just turn it into its more usual form in circle work, I have r squared is going to be equal to x2 minus x1 to be squared plus y2 minus y1 to be squared. This is just the distance formula, or Pythagoras if you prefer to think about it that way, rewritten. And we're going to look at how this formula gets written into your log tables in two slightly different ways. But fundamentally, this is just a distance formula because the distance from our center to any point on the circle is the same, and that distance is called the radius. That's it. That's all we're really doing today. So let's put this into practice in this in our first example here. So we've got the center of my circle is going to be at 1, 2. So I write that down immediately. I see a circle, I see its center, I'm going to write that down. So center is at 1, 2. And I've got a point on the circle that's at 1, 4. What do I need in order to write down the equation of that circle? Well, I need to know its center, which I've got, and I need to know its radius. Now, I don't have the radius yet, but I've deliberately given you an example to highlight something that sometimes happens in exam questions. We don't actually need to do any maths in this particular instance to find out what the radius is, because I'm going straight up. My x values aren't changing here. So I'm going from y is 2 up to y is 4. What must the radius of this circle be? It must be 2. So I know from the graph that r is going to be equal to 2. There's something else that I could also use, even if I wasn't given this 0.14. So something funny we can see about where this circle is sitting. It's sitting at the origin. So it's a tangent to the x-axis is a tangent to our circle. So we could also use that fact to see that because the x-axis is a tangent to our circle, we're going from y is 0 up to y is 2. That could also be used to find that r is equal to 2. So if they give you a graph, or if they encourage you to draw a graph, often it will help you in the question. So again, I'm always stressing this. Diagrams are key to being able to do these questions efficiently and figure out what we need to do. But let's jump into doing this pretending that we didn't spot this fact that r would be equal to 2. So I have the center of my circle and I have a point on the circle. What do I know? I know that the distance between these 2 points must give me the radius of my circle. So I'm going to use my distance formula, which I find on page 18 in my log tables. So I've written down my center and I've written down a point, and I write down my distance between 2 points is going to be my radius, which is going to be, I write this down always, x2 minus x1 to be squared plus y2 minus y1 to be squared, and I label my x1 and y1 x2 and y2. So subbing into that, I get r is going to be equal to the square root of 1 minus 1 to be squared plus 4 minus 2 to be squared. So r is equal to the square root of 2 squared, which is going to be equal to 2 units. Remember, r is a unit, or radius is a unit, is a length, I should say, is measured in units. So now I have the radius and now I have the center. So I know that the general version of my equation is going to look like this. So what am I going to have if I have some points? So I now know that my center is going to be at 1, 2. I know my radius is going to be 2. And I know that I'm going to have all of my points on my circle are going to be at some x, y. So what values of x and y are going to give me this situation here with a center at 1, 2 and a radius of 2. I just sub into my distance formula. So 2 squared, sorry, the distance is going to be equal to the square root of, this is my x1, y1, this is x2, y2. Using my distance formula, I get x1, x2 minus x1 to be squared plus y2 minus y1 to be squared. I'm going to square both sides to get it into the form I'm saying is going to be normal for our formula, for our circle formula, and I end up with x1 minus x minus 1 to be squared plus y minus 2 to be squared. And in general, this is going to be written as r squared is equal to x minus h to be squared plus y minus k to be squared, where h and k are the center of our circle. You can see here the center is 1, 2, and I end up with minus 1 and minus 2. So it is very important, because there's a change of signs here is something that should jump out to people. I have in my formula, I have x minus h and y minus k. And it's very easy if we don't open up page 19 to accidentally write down that the center of this circle would be at minus 1, minus 2, because we have minuses in front of what we're looking for. But if we write down our formula that we are drawing from, if we open up page 19 and write down the formula we're drawing from, it will help us not to make that mistake. So you can see where this version of our circle equation is coming from. Now, what we are going to do is write the other version of our circle equation, and that comes from multiplying out these brackets. So this is the form we're going to end up with, bottom right hand corner of our page. This is on page 19 in your log tables. We're going to multiply out these brackets and simplify a little bit, and we'll end up with the circle equation in this form. It's just multiplying out these brackets. So let's take that. 2 squared is equal to x minus 1 to be squared plus y minus 2 to be squared. 4 is equal to square the first by the second and double it, square the second, plus square the first by the second and double it, and square the second. Gather like terms. Squared plus y squared minus 2x minus 4 y plus 5. And I know that I want to have everything equal 0 because I can see where I want to end up here. So rearranging this, minus 4 from both sides, I end up with x squared plus y squared minus 2x minus 4y plus 1 is equal to 0. Now this is the other version of the circle equation. Now let's have a look at our center and our radius under this schema. So I know that the center of this circle is at 1, 2. So what happens here? I have, I'll write the general version of it underneath here, x squared plus y squared plus 2 gx plus 2fy plus c is equal to 0. And our center is going to be at minus g and minus f. So minus g and minus f is going to be our center. Now, does that work out for our particular situation? Well, we know our center is at 1, 2. So if we have this version here and we have 2g is going to give us our x coordinate of our center. What did we have to do? Well, we multiplied it by minus a half pretty much. So we multiply this number by a minus a half, or half it, and change the sign, and we get the center. Well, if I start out with minus 2 and I half it and change the sign, half of minus 2 is going to be minus 1, and change the sign, and I end up at 1. So that works out. That follows the correct pattern. And minus 4 divided by 2 and change the sign is going to give me 2. So again, you can see why it is going to be very important to open up page 19 in your log tables and double check the form that these equations come in, because this change around is different to the change around we had to do when the equation looked like our brackets not multiplied out down here. So you're going to have to open up page 19 always to double check how you are going to get the center of our circles from given equations, because what you have to do is different depending on which form of the circle equation you are given. In this case, where everything is multiplied out, you take the coefficient of the x, half of it, and change the sign to get the x coordinate of the center, half and change the sign to get the coordinate, the y coordinate of the center. Whereas in our other equation, we had to just change the signs of the numbers in the brackets, of the h and k in our brackets. So it is critical that we're going to open up page 19 for all of these questions to double check how it is we find our center. Now the radius in our original question was just the number squared on the left hand or right hand side of our equation, but here it's a little bit more convoluted. I have this plus a constant type term, and what is that going to do for me? Well, I could see that I ended up adding up a bunch of stuff to get this c term. So my radius is going to be the square root of g squared plus f squared minus c. That's the formula down at the bottom of the page here. G and f, minus g and minus f are the centers of the circle. C is the number on the end here, the constant term on the end here. So that's what we're going to need in terms of our two versions of our circle equation, where we have them left in brackets here. This is the top version of it in our log tables, and the second version at the bottom of page 19 is where we have the brackets multiplied out. We need to be able to interpret and work with both versions of this equation, and now we've seen where they are coming from.